Imagine finding a message in a bottle, but instead of the ocean, it's drifted through space for, well, billions of years. Kind of cosmic time capsule. That's basically what we're talking about today on the Deep Dive. We're looking at this really enigmatic visitor, the 3IATLS comet.
Right, the third interstellar object we've ever confirmed.
Exactly. And our mission here is, to really unpack what the latest sources are saying about it, what makes it so unique, and what it might mean for understanding our galaxy.
And for future discoveries, too. It's quite exciting.
Okay, so let's dive in. The basics. 3IATLS interstellar comet. That means it came from way outside our solar system.
Correct. And it was only just spotted, wasn't it? July 1st, 2025.
That's right, by the ADLS Survey Telescope, the one down in Chile.
Now, what's really fascinating here, beyond just where it came from, is how incredibly old it seems to be.
Old how?
Well, the estimates put it at over 7 billion years old.
7 billion! Seriously.
Seriously. Think about that. Our own solar system is, what, 4.5 billion years old? This thing formed way before our sun even ignited.
So it could be the most ancient comet we've ever actually observed.
Potentially, yes.
Yeah.
A genuine fossil from the early universe, really.
Okay, wow. And get this, the story gets even cooler, right? Its origin point.
Ah, yes. That's maybe the most compelling part. Unlike Oumuamua or Borisov, this one seems to trace back to the Milky Way's old thick disk.
Which is, explain that for us.
It's a region of our galaxy, populated by older stars. Stars formed early in the Milky Way's history, often poorer in heavy elements. It's like a fossil record of the galaxy's youth.
And we've never seen material from there up close like this before.
Not directly like this, no. That's why it's such a pristine relic. It literally embodies the conditions from billions of years ago.
So it really is a time capsule.
In the most literal sense, yes. Its age, its origin. It gives us this unprecedented window into the chemistry, the physics of star and planet formation back then.
And wasn't there research predicting what it might be made of? Something about water.
Yes, Matthew Hopkins' work suggests it should be rich in water ice, which is, fundamental. Water's crucial for planets, for life.
Finding ancient water ice from another part of the galaxy, that tells us something important.
It could tell us how common water was way back then in those primordial environments.
And it's not just sitting there, right? It's active. We're seeing stuff happen.
Correct. It's already outgassing. We can see vapor, dust. It's forming a coma, that fuzzy atmosphere, and a tail.
Which is great for us, scientifically speaking.
Absolutely. Because as it sheds that material, we can actually analyze its composition directly. We couldn't really do that with Oumuamua, which was much less active.
And it might be bigger, too, than the other two.
Early signs suggest it could be, yeah. Possibly larger than both Oumuamua and Borisov.
Okay, so if we zoom out a bit, what's the bigger picture here? What does analyzing this ancient ice and dust tell us?
Well, it gives us clues about how common essential volatiles were. Things like water, methane, ammonia, the building blocks.
Right, the stuff you need for planets, especially rocky ones, maybe.
Exactly. And because we're seeing it happen now in real time, we can test our models. Things like the Tatahi-Oxford model that tries to predict what these objects should be like.
So we get immediate feedback, like, okay, our theories about galactic chemistry are on the right track, or, oops, need to adjust that.
Precisely. It's validation or refinement happening right before our eyes.
And there's that other implication, too. The idea that these things aren't just relics, they might be active participants, like seeding the galaxy.
That's a fascinating possibility. These objects traveling across the galaxy for billions of years. They could literally be transporting essential elements, compounds, maybe even the ingredients for life between star systems.
Influencing where and how new stars and planets form over cosmic time. Wow.
It paints a picture of a much more interconnected galaxy. And, finding 3IATLS makes us way more optimistic about finding more of these.
Especially with new telescopes coming online.
Exactly. Like the Vera C. Rubin Observatory. The predictions are, well, pretty exciting. Some models suggest Rubin could find maybe 50 interstellar objects in the next decade alone.
50. Okay, so we're moving from spotting these things by chance to actually studying them systematically.
That's the hope. Building up a real catalog, understanding the population. It's a whole new phase.
And here's something really cool for you listening. You might actually be able to see this thing.
That's right. Predictions are it could be bright enough for a decent amateur telescope later this year and into early 2026.
Imagine seeing a 7 billion-year-old visitor with your own eyes. That's incredible.
It really is. And it makes you ask, what does this comet really represent? It's more than just rock and ice.
It feels like a signpost.
a harbinger perhaps, of a new era in astronomy, pushing what we can observe, what we can know about our galaxy's deepest history. It's expanding our horizons, quite literally.
So wrapping this up for you, what's the takeaway? This ancient visitor, 3i@Teals, isn't just a curiosity. It's giving us tangible evidence about the galaxy's earliest days.
And it suggests this constant exchange, this cosmic ecosystem that's been operating for billions of years.
Right. So the final thought to leave you with is just consider that, this constant movement of material across the galaxy. If these messengers have been traveling for eons, carrying ancient secrets, maybe even the seeds of life, what else are they going to tell us about the universe's past and maybe even its future?
It really opens up some profound questions.